Well, welcome back, everybody. Now that you know about how the genotype of the parent affects the traits carried by the gametes, we can start to look at how, if we know the genotypes of two parents, we can predict the types of offspring they will produce. So let's get started on that. We use the probability of each kind of gamete to predict the probability of the genotypes and the phenotypes of the offspring for a given mating. To do this, we use a Punnett Square, or perhaps better called a Punnett Table. So, for example, suppose in pea plants there is a dominant allele, big H, that results in tall plants, and a recessive allele, little h, that results in short plants. We can use these Punnett squares to answer questions about the frequency of different types of offspring for a given mating. For example, what are the expected genotypes and phenotypes in the offspring for a mating of two heterozygotes, big H, little h, by big H, little h? And so you can see these are two tall plants, but they each carry the short allele. So here is a Punnett table on the right, and what we do is the mother's gametes are placed on the left side of the box, so she can produce either a big H or a little h. And the father's gametes are placed on the top. He can produce either a big H or a little h. And at this point I want to say it does not matter where you put the mother and the father as long as you put the two different parents on opposite sides. So you don't always have to put the female down here and the male up here. You can do it in whatever order you want. Once we have placed the gametes here, we can build the genotypes of the equally likely offspring. So here's an offspring that will have the big H genotype, and here's an offspring that will have the little h genotype, and here are two offspring that will be heterozygous, big H, little h. And since the gametes of any parent are equally likely, each box contains an equally likely offspring. You can prove that to yourself mathematically if you'd like, or you can take my word for it. So in this case, we expect that 1 in 4 offspring will have the genotype big H, 2 in 4 offspring will have the genotype big H, little h, and 1 in 4 offspring will have the genotype little h. In other words, we'll get 1 homozygous dominant individual, 1 homozygous recessive individual, and 2 heterozygotes. But what about the physical appearance of the offspring? Well, we know that the genotype big H and big H, little h will produce tall plants, while the genotype little h will produce short plants. So if we look at the offspring here, then we can see that 3 out of the 4 will be tall, 1, 2, 3, and 1 out of the 4, right here, will be short. So we can say that we will expect in the offspring a ratio of 75% to 25%, or of 3 to 1, of tall to short plants. What I've done here is I've put together a list of instructions that I suggest you use until you get totally comfortable doing Punnett squares. So here are the steps you should do. First, write down the genotypes of each parent. And I see so many students make mistakes in Punnett squares because they don't do this step. In this case, we're going to cross a big R with a little r. So that would be a red flower with a white flower, let's say. Then you determine how many kinds of equally likely gametes each parent can make. In this case, the heterozygote can make a big R or a little r gamete, while the homozygous recessive individual can only make a little r gamete. As a result, the Punnett square has the dimensions of the number of gametes, in this case 2 by 1. If you want to make the square, the full square, you can, but you can reduce it to smaller sizes in many cases and save yourself a lot of work. I'll talk more about that in a second. Next, you fill in the gametes on the appropriate side of the box. In this case, you'd put a little r on the left and a big R and a little r on top. And then you fill in the genotypes of the offspring. In this case, as we'll see in a second, the only offspring that are produced from this cross are a big R, and a little r. And then you answer probability questions about the offspring's genotypes and phenotypes. So let's take a look at that. Here we have the cross, big R, by little r, or in other words, a heterozygous red flower by a homozygous recessive white flower. The white flower can only produce gametes with little r, and the red flower can produce gametes with big R or little r. And so you can see there are only two possible genotypes for the offspring, a big R, like this parent, or a little r, like this parent. And they're each as likely, so we expect them in a 50-50 or 1-to-1 ratio. Now, before I told you can make your Punnett Square 2 by 1 in this case, because this one can only produce one kind of gamete. I'm going to show you that now and prove that to you true. Here I've put the second R in, saying, oh, this one can produce a little r and a little r. And you can see we get two big R, little r offspring and two little r offspring. In other words, 2-to-2 or 1-to-1 or 50-50 ratio of heterozygous red flowered plants and homozygous recessive white flowered plants. Well, at this point, the thing for you to do is to use that list of instructions to start solving problems using Punnett squares. Until next time, look at Punnett squares, ask biological questions, bring them to class, and I'll see you soon.